Hello students, in this session we will cover exercise 3.3 second question. We will do a word problem using elimination method from the chapter 3 pair of linear equations in two variables. The second question, form the pair of linear equations in the following problems and find their solutions if they exist by the elimination method. First one, if we add 1 to the numerator and subtract 1 from the denominator, a fraction reduces to 1. It becomes half if we add 1 to the denominator. What is the fraction? Okay, here there are numerator and denominator, so let the numerator equal to x and the denominator equal to y. So let the numerator equal to x and denominator equal to y. So the fraction is equal to x by y. So the first condition is if we add 1 to the numerator. If we add 1 to the numerator, see case 1. Okay. If we add 1 to the numerator plus 1, what do we get? X plus 1. Okay. And if we subtract 1 from the denominator, see, if we subtract 1 from the denominator, it will be y minus 1. Okay. And if we do these two things, then the fraction reduces to 1. So the original fraction is x by y. So the fraction reduces to 1. So the fraction is equal to 1. So the new fraction is equal to 1. So it will not be x by y minus 1. So this is not the thing. Okay. If the question is asked fraction reduces by 1, if the question is asked fraction reduces by 1, then it will be x by y minus 1. But here it is told fraction reduces to 1. 2 means it will be 1. Okay. 1 means it will be, so the final value will be 1 here. Okay. Okay. This is the thing you need to remember. Okay. This word by and to are so different. Okay. So what is the equation here? So the fraction is 1, numerator is x plus 1 and denominator is y minus 1. So the fraction will become 1. So if we take y minus 1 to the right side, it will be x plus 1 equal to y minus 1. Okay. Here take these two terms to the left side, x plus 1 minus y plus 1 equal to 0. X minus y plus 2 equal to 0. Take this as first equation. Okay. And what is the second condition given? Second condition given is it becomes 1 by 2. It becomes 1 by 2. But when? If we only add 1 to the denominator. See, the numerator is not given. So the numerator will not be changed. No changes will be done to the numerator. Okay. Here what is the thing? If we add, see here, this is the case 2. If we add 1 to the denominator plus 1 will become y plus 1. So the numerator is as it is. So the fraction is equal to numerator by denominator. Numerator is x, denominator is y. So here the fraction becomes 1 by 2. So this will become 1 by 2. Okay. So here we will solve this equation. 2x equal to y plus 1. Bring these two terms to the left side. 2x minus y minus 1 equal to 0. Okay. This is the second equation. Okay. We will solve using the elimination method. This is the first and that is the second. We will write the first equation, x minus y plus 2 equal to 0. Okay. This is the first equation. Here the coefficient of y is minus 1 and coefficient of y is minus 1 in both the equations. So we will just subtract both the equations. We don't have to multiply. Okay. First equation minus second equation is 2x. Okay. First equation is x minus y plus 2 equal to 0, and second equation is 2x minus y minus 1 equal to 0. Okay, subtract these two. X minus 2x is minus x. Okay, minus y, minus of minus y is plus y. Minus y plus y cancels, and 2 minus of minus 1 is plus 1. Plus 2 plus 1 equal to 0. So minus x plus 3 equal to 0. Minus x equal to minus 3. So x equal to 3. So we got the value x as 3. We will substitute x value in first or second equation. Substitute x value in first equation. Okay, here x is 3 minus y plus 2 equal to 0. Here 5 minus y equal to 0, y equal to 5. Okay, we got x equal to 3 and y equal to 5. So the fraction is equal to x by y, that is 3 by 5. Okay, we can verify this. We can verify the fraction if this is correct or no. Okay, verification. Okay, here what is told? Here the if we add 1 to the numerator and subtract 1 from the denominator, if we add 1 to the numerator and subtract 1 from the denominator, what it will be? See here 3 plus 1 is 4 and 5 minus 1 is 4. So the fraction reduces to 1. This is correct. And the second condition is it becomes 1 by 2 when we only add 1 to the denominator, no changes in numerator. Okay, when we add 1 to the denominator, so denominator plus 1 equal to 5 plus 1 is 6. So numerator is as it is, 3 by 6, that is 1 by 2. Okay, this is also correct. So this answer 3 by 5 is correct. Okay, the next one, 5 years ago. 5 years ago means before 5 years. Okay, Noori was thrice as old as Sonu. Okay, here two people are there, Noori and Sonu. So let the age of Noori equal to, this is the present age. Okay, let the present age of Noori is equal to x years and the present age of Sonu is equal to y years. Okay, before 5 years, 5 years ago, what is the scenario? 5 years ago, Noori will be thrice as old as Sonu. So 5 years ago, the age of Noori will be x minus 5. So before 5 years, any person will be the present age minus 5. Okay, and 5 years ago, the age of Sonu will also be y minus 5. Okay, so this scenario is Noori was thrice. See, Noori was thrice. Noori age equal to thrice, 3 times as Sonu's age, equal to 3 into y minus 5. Okay, let us solve this. X minus 5 equal to 3y minus 15. Let us bring these two terms to the left side. X minus 3y minus 5 plus 15 equal to 0. So x minus 3y plus 10 equal to 0. First equation. Okay, now what is the second scenario? 10 years later. Here 10 years later, that means after 10 years. After 10 years, the age of Noori will be x plus 10. Okay, the age of Sonu will be y plus 10. Okay, the scenario is Noori will be twice as old as Sonu. Noori will be twice, 2 times as old as Sonu. Let us solve this. X plus 10 equal to 2y plus 20. Bring these two terms to the left side. X plus 10 minus 2y minus 20 equal to 0. X minus 2y plus 10 minus 20 is minus 10 equal to 0. Second equation. Okay, See, we will solve these two equations with the help of elimination method. Okay, here the coefficient of x is 1 and the coefficient of x is 1 in both the equations. So we will just subtract them. So first equation minus second equation is x minus 3y plus 10 equal to 0 and x minus 2y minus 10 equal to 0. Okay, we will subtract. X minus x is 0 and minus 3y. See here, minus of minus 2y is plus 2y plus 10 minus of minus is plus 10 equal to 0. So here minus 3y plus 2y is minus y plus 20 equal to 0. So y equal to 20. We got y equal to 20. That means Sonu's age. Sonu's age is 20 years. 20 years. And what is the age of Noori? To find out the age of Noori, substitute y value in first or second equations. In first we will substitute. Okay, here x minus 3y, 3 into 20 plus 10 equal to 0. Here x minus 60 plus 10 equal to 0. Here x minus 50 equal to 0. X equal to 50 years. So the age of Noori equal to 50 years. Age of Noori is 50 years. Now we can verify them. Okay. See here, two cases. So 5 years ago, age of Noori will be 50 minus 5 is 45. Age of Sonu will be 20 minus 5 is 15. So Noori is thrice. 45 equal to 3 into 15. This is correct. And the second scene is 10 years later. 10 years later, what is the age of Noori? Noori will be 50 plus 10 is 60 and age of Sonu is 20 plus 10 is 30. So Noori will be twice as old as Sonu. So Noori will be twice as old as Sonu. So this is also correct. So the ages of these two are correct. Okay. Next one. Third one. The sum of the digits of a two-digit number is 9. Also 9 times this number is twice the number obtained by reversing the order of the digits. Find the number. See, if you take a number, for example, if you take a number 54, how do you write it? Do you write it 5 plus 4? No. You write it 50 plus 4. So what is 50 here? 5 into 10 plus 4. The same way, if the number is AB, you will not write A plus B. You will write 10A plus B. Okay. This number is represented as 10A plus B. Okay. Here, the sum of the digits of a two-digit number. So let the two-digit number be, let the two-digit number equal to 10A plus B. Okay. Let the two-digit number is 10A plus B. Also, here what is the condition given? The sum of the digits. The sum of the digits. See here, the two digits are A and B. Here the two digits are A and B. Okay. Here it is told sum of the digits equal to 9. Okay. This is the first equation. And what is the second condition given? 9 times this number. 9 times of this number. 9 times of 10A plus B is twice the number obtained. See, this is twice, 2 times the number obtained by reversing the order. See, if we reverse the order, that means, see, if here we reverse the order, it will be BA. Now, how do you represent this one? 10B plus A. Okay. We will write the same here. See, it is 2 times, twice the number obtained by reversing the digits. So, it is 10B plus A. Okay. Now, we will simplify this. 90A plus 9B equal to 20B plus 2A. You subtract this. 90a minus 2a is 90a minus 2a is 80. 8a equal to 20 minus 9 is 11b. Here a by b equal to 11 by 8. 88. That is 1 by 8. Okay. Here we got the second equation as a by b equal to 1 by 8. So here when you multiply this, you get b equal to 8a. You take this as second equation. Now here in the first equation and in the second equation, coefficient of b is same. Coefficient of b is same. So here in the second equation, let us take the 8a to the left side. Minus 8a plus b equal to 0. Okay. This is second equation. Okay. Coefficient of b is 1. It is same. So we will subtract the first and second equations. What do you get? A plus b equal to 9 minus of 8a plus b equal to 0. Okay. Here a minus of minus 8a is plus 8a. Here b and minus b gets cancelled. Equal to 9 minus 0, it is 9. Here 9a equal to 9. A equal to 1. You got the value a as 1. Here you substitute a value in second equation. What do you get? Minus 8, a is 1 plus b equal to 0. So b equal to 8. You got the value b equal to 8. So here the number is, what is the number? The number is, it is 10a plus b. So it is 10 into 1 plus 8. It is 10 plus 8, that is 18. Okay. The number is 18. Next one. See, Meena went to a bank to withdraw 2000. She withdrew 2000 and she asked the cashier to give her 50 rupees and 100 rupees notes only. Okay. Meena got 25 notes in all. She got 25 notes in all. Find how many notes of 50 rupees and 100 rupees she received. So she asked the cashier to give 50 rupees and 100 rupees only. Okay. So let us assume she got 50 rupees notes. She got 50 rupee notes A. That means the number of 50 rupees notes are A. Okay. And the number of 100 rupee notes are B.